Good morning, students. In our last class, we will discuss about the experimental study of the photoelectric effect. In that, we covered first one, that is the intensity, how the intensity relates with the photo current, right? So, in this today topic, we will discuss the second relation. So, in the last class, we find that the intensity of the light, sunlight, source light which falls onto this photosensitive plates, the electrons are emitted. So we find the relation, that is the photocurrent is directly proportional to the intensity of incident light. So this is the relation. We get the photocurrent and that of the intensity of the incident light, keeping the potential across this plate, that is potential across the plate A, and also the frequency of the light, that is source light, is kept constant, right? So this is the relation. We get the photocurrent to the intensity. So here we get the curve, that is the linear curve. So photocurrent is directly proportional to the intensity of incident light. So today we will discuss the effect of potential difference potential difference between the plates that is C and A, between the plates C and A on photocurrent. So this one is the second experimental observation. So here, keeping in this first one is for the study of the potential difference between the plates. So here we have the potential that is given by the battery. So here we have potential and here also potential. So keeping this plate, that is positive potential. So here we given the potential as positive potential when the source emits the radiation which are made to incident on this photosensitive plate, right? Made to incident on the photosensitive plate. Then what happens? The electrons are emitted from this photosensitive plate. That is, from the plate C, the electrons are emitted. These electrons are attracted towards the plate A because the plate A is positively potential, right? Then what happens? The electrons flows in the external circuit. That is, here we connected positive, so here it is positive, and plate C is negative, right? So if you observe here, the electrons are passing in the external circuit, then we get the readings. That one is the photocurrent readings we are getting in the microammeter. When we connected this one anode, that is the plate A, we connected to the positive potential. That is, positive potential is given to this plate A. That is, for this we keeping intensity and frequency of incident light is constant. So here for this observation, we kept the intensity and also frequency is in constant. That is, here the intensity and frequency. The frequency is denoted by nu and the intensity is denoted by I. So these two are kept constant. Then we given the positive potential to the plate A. Then electrons are emitted from the photosensitive plates, which is collected, that is attracted or collected by the plate A. Then electrons will move in the external circuit, then we get the readings in the microammeter. That is, photo current readings will get in the microammeter. So next, here we are varying the potential in the plate A, right? So we are varying the potential. That is, we are increasing the potential in the plate A. Then what happens? The more number of electrons are attracted by the plate A, because here we are increasing the potential. That is, increasing the potential, that is accelerating potential on plate A. That is positive potential, increasing the positive potential on the plate A. So here we have the plate A that is connected to the positive terminal of the battery. Here we are getting the positive accelerating potential. So here we are increasing the potential. That is, here more positive charges are collected. By this, the more number of electrons are attracted. So if, for example, if I kept initially we have the potential V1, then we get some readings in the ammeter, that is photocurrent readings in the ammeter, that is I1. Similarly, next we further increase the potential on the plate A, that is increasing nothing but we are giving extra potential by using the battery. Here few more charges are accumulated on the plate A, nothing but this one is positively potential. Its potential is goes on increasing, that is we are increasing the potential V2. Then we observe that the readings in the microammeter is also increases, because here the number of electrons emitted will gains the energy and attracts towards the plate, hence we are getting the more current that will be shown in the microammeter. So if we further increase V3, then we get current I3, that is increasing. So if we given 5 volt here, for example, here we get 10 microampere current. Then further if we increase the potential to 10 volt, further here we getting the 20 microamperes. So if you observe here, we are increasing the potential. As we increasing the potential on the plate A, that is positive potential, then current also we are getting, photocurrent is getting increasing, right? So if you observe here, I1 value is 10, I2 is 20. If you further increase for 15 volt, then here we get 30 microamperes. This is just for reference I am telling. As we increasing the positive potential on the plate A, then the photocurrent also goes on increasing. For particular potential, for example, some for particular potential V5, we get the maximum current, that is I5. So that is nothing but all the electrons which are emitted by the plate C is attracted by the plate A. That is, all the electrons which are emitting from this photosensitive plate are attracted by A. Hence here we are getting the maximum current. If we further increase the potential, that is V6 on plate A, then we get the current, that is I5 only. That is, for example, here we are getting 50 microamperes for 20 volts. Then if we increase the potential for 25 volts, then only we are getting the same current. This means that the maximum current we are getting, that is the current is saturated. After, if we further increase the voltage, we are getting only the maximum current. After this, the current will not goes on increasing. So this current we call as saturation current. For a particular voltage, we getting the maximum photo current in the circuit. So that we call as saturation current, right? The maximum current for a particular voltage on the plate A. So that current we call as positive, that is saturation current. So here we are finding the relation between potential difference, that is V, potential is denoted by V, and to that of the photocurrent, that is I. So as we increasing the potential on the plate A, that is positive potential on the plate A, then the photocurrent will also goes on increasing. For a particular value of the potential on the plate A, we are getting the maximum current, because the total number of electrons which are emitted by this photosensitive plate is attracted by the, or it is, because here we have positive and we have negative, because of that these electrons are attracted, that is total number of electrons are attracted by the plate, hence we are getting the maximum current. After that, if we increase the potential, then we get only the maximum current only. For if we put V7, that is for 30 volt, then also we getting the current 50 microamperes. So this means that the current is saturated, that is the maximum current. So by this we can say here the first point by this observation. So here we can say, if the positive potential is increasing, that is we are increasing the positive potential. Here the positive potential on plate A, so this one is important, that is positive potential is increasing, then increasing on plate A, then photocurrent also increases. So this one is the first point. As we increasing the potential on this plate by using the battery, that is we connected through the commutator, this potential A is positive with respect to the plate C. As we increase the positive potential in the plate A, then photocurrent will also increases. Next, and increases and attains a maximum current, and attains a maximum current. So this maximum current we call as, so the maximum current attained for a particular voltage is called saturation current, right? So that current we call as saturation current. So saturation current is nothing but, for a particular voltage we are applying at the plate A, then we get the maximum current. So further, if we increase the potential on the plate A, then also we getting the same current. That current we call as saturation current. So current is nothing but charges flowing per second, that is number of charges flowing per second or number of electrons flowing per second. So saturation current is nothing but the maximum current. So in saturation current what happens, maximum number of electrons are flowing from this circuit, right? To understand this one, that is the saturation current. So when we connected positive potential to the plate A, right? So this one is the first observation when we potential is applied to the plate A, right? So next, second one is So now connect here. Now what we'll do is, now we applied a positive potential to the plate A. Now with the help of this commutator, we are applying the negative potential to this plate A. Right? So this one is the plate A. With the help of this commutator, we are applying negative potential. With the help of the commutator, we are applying negative potential. If you observe here, the negative terminal is connected to the plate A. So here what happens? The number of charges accumulated on this plate is minus. Right? So when a light which incident on the photosensitive material, the electrons are emitted. So here the electrons are emitted and it moves in this direction. If we observe here also we have electrons. On this plate also we have electrons. That is, these two are the like charges. Here electrons and here also electrons. So like charges is nothing but, from the properties of charges, like charges are repulse each other. So it won't able to reach to the plate A. Right? So understanding this one. So the electrons are emitted because the suitable frequency which falls onto this plate. So due to this plate is photosensitive, the electrons are emitted. So these electrons are emitted will not reach to the plate A because here in the plate is applied by the negative potential. Some of the few electrons which have high energy will reach this plate. Right? The electrons which have high energy will only reach this plate because here also negative and here also negative. So like charges will not attract, they will repel each other. Hence all the electrons which are emitted from this plate will not reach to the plate A. Only few number of electrons reach to the plate A. So this shows that number of electrons flowing in this circuit will reduces. That is, its value decreases. The number of electrons decreases, nothing but the photocurrent is decreasing. Right? As we further increase the potential on this plate, that is, more number of electrons are accumulated on the plate, then what happens? These electrons which flows towards the plate A decreases. Further, if we increase the potential, then the number of electrons reaching this plate is goes on decreasing. If the number of electrons goes on decreasing is nothing but the current is decreasing. So for a particular potential, so if this potential is further increased for a particular potential, no electrons will reach this plate. So nothing but the current in the external circuit is 0. Right? That is, I value is equals to 0. That is, current is 0. So this means that there will be no flow of current in this circuit. That is, there will no electrons will reach this plate. So for that potential we are calling as cutoff potential or stopping potential. The potential which stops the flow of electrons in the external circuit. So that potential we call as stopping potential. Understand this one? In the last case, we connected the plate A with the positive terminal. Now, in the second case, we connected this plate A to the negative terminal with respect to the plate C. Right? As we increasing the potential, for example, initially V1, that is the potential we applied on the plate A. Initially, we kept that is for 5 volt. Then here also negative electrons and here also electrons. Only high energy electrons will reach this plate and flows through the circuit. Then we getting the current, that is, for example, 2 microampere. That is very less current is flowing in this external circuit. If we further increase the value V2 to the 10 volt, then here the number of electrons, that is negative charged electrons on this plate, is increasing. Then the number of electrons which reach the plate also decreases. So that means the flow of current in the external circuit further decreases. That is I is equals to 1 microamperes. If we further increase the voltage, which voltage it is? Negative voltage. In the last we applied the positive voltage. Here we are applying the negative voltage. Hence, if we further increase to 50 volt, then here we have more number of electrons. So here from the electrons which are emitted will not able to reach the plate because like charges repulse each other. Hence, the current will becomes zero for a particular negative voltage. When the current becomes zero for that voltage, for this particular voltage, then this voltage we call as cutoff voltage or stopping potential, right? So understand this one. When we apply the voltage, that is we increasing the voltage, then we are noting the readings in the microammeter for the particular voltage, either it may be 15, 20, 25, any voltage. For that voltage the current must be equals to 0. So that voltage we are saying that one we calling the name as cutoff voltage, or in the other name we have stopping potential, right? So these are the two cases we studied. When we applied the positive potential, that is we get in the maximum current, that current we call as saturation current. When we connected negative potential to the plate A, so in that we is getting the cutoff voltage, that is the current flows through the circuit is 0, right? This is the observation which we did in the experimental setup, that is potential difference with respect to current. So potential difference is voltage, current is I, that is photo current is I, right? So for this, if we write the statement means, if the negative potential is applied to the plate A, if the negative potential is applied to plate A with respect to plate C, that is with respect to plate C, then increasing the negative potential, current becomes 0. So when current becomes 0, so that potential we call as, and the potential called as stopping potential or cutoff potential. So in the word it says that stop, that is it stops the electrons which are coming to that plate. So that potential we call as stopping potential. That is when the current is 0 in the external circuit, that is photo current is 0 when for a particular voltage, so that voltage we call as stopping potential or cutoff potential, right? So this is keeping for the intensity I, right? So keeping frequency of the incident radiation and intensity of the incident radiation kept these two as constant. These two have some fixed values, so these will not change for every observation. That is, as we change the voltage, these values will not change. So these values are kept in constant, right? So here keeping intensity and frequency of the incident light is constant. Next, if we plot the graph, that is potential difference to that of the photocurrent. So this one is plate A in call as collector plate or plate A potential. Along x-axis we are taking plate A potential, that is plate A can be changes by using the commutator, that is we are changing the polarity of these plates, that is one time we are connected to positive and one time we are connected to negative. So this one is the plate A potential and along y-axis we are taken photo current, right? So if we plot the curve, then here this one is the potential, right? So for the particular potential, this current is 0. So 0 nothing but it should be in the x-axis. For negative potential, so here we have the positive, here we have the negative. So in the negative potential, the current must be 0. So that starts with origin here. So this one V naught, that is VO. So VO is called as stopping potential or negative potential. So if we draw the plot, right? So we get the curve like this. So V naught is the stopping potential. It goes on increasing. So this one is the current. This curve represents the current. So saturation current is for up to here. If you observe here, for smaller values, the curve is increasing. That is, the current is increasing. For somewhere here, the current remains constant. That is straight line. That is parallel to x-axis, right? So this current we call as saturation current. So this one, if I take extended in dot length, so this is the saturation current, right? So this is the origin O. From here to right side we are giving the plate A positive potential. So from here to in the left side we are giving the negative potential. So this one we call as negative potential or retarding potential. So retarding is nothing but opposing. The flow of electrons are opposed by these plates. So that plate is the potential V naught. So V naught is the stopping potential. So from here it goes on increasing. Suddenly will not falls to 0. So if we apply the negative potential to the plate A, suddenly the flow of electrons will not stop. So initially for certain voltage, high energetic electrons are flows to the plate, that is which falls onto the plate and flows in the external circuit. So that's why we are getting this curve. So if when we apply the negative potential, then it suddenly stops the flow of electrons, nothing but here only we get V naught, that is 0 value from here only. So we will not get this potential, right? So this one is the negative potential. So this is for the intensity I. Keeping this intensity, that is, if we given some intensity is 10, then for that intensity we plot the curve for photocurrent to the plate A potential or collector plate potential. right? So next, if we increase the intensity, that is, if we changes the intensity I to I1, keeping as it is, that is keeping frequency fixed to discuss all the observation, only we change the intensity I1. So throughout the observation, the I1 should be fixed value. That value is the I1. So what happens? First, we connect same procedure. First, we connect positive terminal here, the number of flow of electrons, and we note the readings, and we get some value for a particular voltage. Here we get the maximum number of electrons which are collected on this plate, and we get the maximum current, right? So that current is the saturation current. Next, we change the polarity from plus to minus for the intensity I1. Then similar high energy electrons are attracted by these plates, and the flow of current is reduces for a particular voltage. The ammeter shows the zero readings. That means the circuit will not flow any current, right? For that, if we if we plot for that graph, so here we will observe. So from here, this one is for the, if we intensity I1, keeping intensity initially we have I. So next we change the intensity for this whole experimental study to I1. Then we get the curve like this, so which is drawn in the red color. This shows what, that here this dotted line represents what? Here we have the saturation current I. So here we have the saturation current I. So if you observe these two, the blue dotted, that is the intensity, for intensity I, the saturation current is less. For red line, that is for intensity I1, the saturation is more. But here the stopping potential is same for both the intensities. So understanding this one, if we observe these two curves, that is I1 and I. So here we increase the intensity, right? So in the last discussions, we discussed that intensity, that is intensity of the sunlight is directly proportional to the photo current, right? So in the last discussion, that is first one, effect of the intensity with respect to, that is on the photo current. In that we show that the intensity is proportional to the photo current. That is, as intensity increases, automatically photo current also increases. So photo current increasing nothing but the maximum current also increases. Here, if we increase intensity, automatically the saturation current will also increases, right? So next, if we draw for further intensity I2, and if we observe the experimental result, so this one is I2. That is, we are increasing the intensity of the radiation. By this observation, we can say that this saturation current is more. That is, the saturation current in I2 is greater than I1, greater than I2, because the number of electrons emitted is directly proportional to the photo current. That's why if we increase the intensity, the number of electrons emitted will be more. Hence, for that reason, the saturation current is also increasing. But the potential, that is, which potential it is? Stopping potential. So stopping potential for all the intensities remains same, right? This means that this stopping potential is independent of the intensity. So whichever intensity we can give, but the stopping potential remains for all these cases remains same. For example, the stopping potential for the intensity I is 5 volt, that is minus 5 volt. Then the stopping potential for I1 is also minus 5 volt, and also for I2 it is minus 5 volt only, right? So by this observation we can say that the stopping potential is independent of the intensity. So understanding this one, this stopping potential is independent of the intensity, that is there will be no relation for the intensity and stopping potential. Whichever intensity we are giving, the stopping potential will be getting the same stopping potential for every intensities, right? So this is the discussion of the effect of potential difference on photo current, that is photo current versus potential difference. Towards right we have applied positive potential, towards left we apply the negative potential, right? So this is the conclusion. So in that first conclusion is what? For the positive potential, if we apply positive potential for the plate A, as we increase the voltages, the current also increasing. For a particular voltage, the current reaches the maximum value. After we increasing the potential, then also the current will not increasing. So that current we call as saturation current, right? That one is the first observation when we made the plate A with the positive potential. Next, the plate A is connected to the negative terminal. That is, we are applying the negative potential to the plate A and we increasing the negative potential. The high energy electrons will absorb by the plate A and hence it causes the flow of current. That is, the flow of current goes on decreasing, and for a particular voltage the current becomes 0. So that current, that is that voltage we call as cutoff voltage or stopping voltage. So these are the two observations. Next, further one more observation is that if we changing the intensity, that is we are changing the intensity of incident radiation, then the saturation current is goes on increasing for varying intensities, but the stopping potential remains constant for all the intensities. By this we can say that the intensity and the potential, that is the stopping potential, will be independent of that of the intensity. So V naught will not depend on intensity. So the intensity will depend only on the photo current, right? So these are the three observations made in this topic, that is potential difference to the photo current, right? So we can say here the third point, for a given frequency the stopping potential is stopping potential is independent of intensity. So this one is the third observation. So we have to remember these 3 points. So one is saturation current. So in this topic we discussed is the keywords which are saturation current. So saturation current is nothing but the maximum current. So maximum current in what happens? The number of electrons per second is more. Next, the second one is stopping potential. So stopping potential is when we apply the negative voltage, the flow of current will reduce, and finally for a particular voltage the current becomes 0. So that one we call as the stopping potential. And the third one is the frequency is independent of, the potential is which potential? Stopping potential. There will be a difference, positive potential, negative potential and stopping potential. Positive potential means we are giving positive charges to the plate. Negative potential means we are giving negative charges to the plate. Stopping potential means when we given the stopping potential, if we say the stopping potential is 10 volt, then the current is 0, right? So we can directly say that one is the current is 0 in the circuit. So right, so this one is independent of the intensities. So here these 3 points along with this graph is important. For 3 months they asked the which one it is the experimental study of write the experimental study of potential difference with respect to the photo current. That is, we need to write the 3 points: what happens when positive potential, what happens when negative potential, and what happens when we increase the intensity, right? So in the next class we will discuss about the frequency. Here for all the observation, keeping this frequency and intensity constant. For further discussions, we changes the intensity. For whole discussion, we changing the intensity. Not for every discussion, we are changing the intensity as we did in previous. That is changing the intensity. We are noting the readings of the photo current, right? So initially for I, we did whole both for positive and negative, and we next change the intensity for both positive potential and negative potential, and later we change the intensity to I3. So for every experiment we have the curves like this, right? So in the next class we will discuss the effect of frequency with respect to the photocurrent. There also we will get these points, that is saturation, stopping potential, and also this graph. Right? Once recall these concepts, then only we can understand the frequency. Right? In the next class we will continue. Thank you.